The function of the idle speed control actuator is controlling the idle speed according to engine conditions such as temperature, throttle position, engine speed, and different load factors. The ECM compares the actual engine speed with the target speed. The ECM transmits a signal to the idle speed actuator, which adjusts to the target speed by increasing the bypass air when the idle speed is too low and decreasing it when the idle is too high. For example, when the engine is started in cold weather, the engine control module, or ECM, will give the engine cold start enrichment and will increase the engine's idle speed to approximately 1,000 RPM or more. The idle speed control actuator is responsible for this increase. As the engine reaches operating temperature, the enrichment will be eliminated and the idle speed will be reduced to a predetermined speed. This speed will be maintained regardless of electrical loads on the alternator and, to a certain extent, mechanical loads. There are rotary type and step motor type idle speed actuators. The rotary type actuator is located in the throttle body. The rotary valve on the armature shaft opens the air bypass passage until the required idle speed is reached, regardless of engine load. Voltage is applied alternately to the rotary actuator's two winding coils and generates opposing forces on the pivoting armature. The rotary valve assumes the opening angle, which corresponds to the pulse duty factor of the applied signal. This means that the bypass opening can be adjusted by varying the pulse duty factor. The rotary type actuator has two winding coils, whose names are opening coil and closing coil, respectively. The ECM controls the two coils. The opening coil opens the valve. The closing coil closes the valve. Each coil receives opposite signals from each other alternately. In other words, the closing coil turns off when the opening coil is on. On the contrary, the closing coil turns on when the opening coil is off. The ECM carries out these on and off motions 100 times per second, which corresponds to 100 hertz. The ECM also controls the on and off time, which varies depending on the engine condition. This type control is called duty control, in which on and off ratio is controlled. For example, in the case of 30% opening duty, the valve remains open for about 30%. Likewise, in the case of 60% opening duty, the valve remains open for 60%. The duty valve of the idle speed actuator is displayed on the current data of the high scan. ISA duty 30% means that the ECM turns on the opening coil 30% to let the opening be 30%, though it will not be displayed in the current data. In case of the closing coil turns on 70% to let the closing be 70% because it is the reverse of the opening coil. There are several ways to check idle speed actuators. First, checking the resistance. Second, checking the waveform. Third, checking the valve operation. Fourth, checking the current data. Firstly, to check the resistance, remove the idle speed actuator connector and measure the resistance of the opening coil and closing coil directly. Through this, we can check the internal coil condition of the idle speed actuator. To check the waveform, measure the waveform at one of the ECM side wires. Idle speed actuator waveform should be displayed as shown in the figure in cranking or idle condition. In the idle speed actuator waveform, voltage at the off state should be the same as the battery voltage. If not, there should be trouble in the power supply system from the battery positive terminal to the idle speed actuator. Besides, voltage should be close to 0 volt as shown in the figure while it's on. If not, there should be trouble with the ECM or wirings from the idle speed actuator to the ECM earth. Next is checking operation. Remove the idle speed actuator from the engine and operate the engine. Then check for valve operation as given duty percentage and any noise while operating. Through this, we can check the mechanical problem and noise of the idle speed actuator. The next one is checking the current data. The ISA duty in the current data is a calculated figure by the ECM to control the ISA depending on the engine condition. Use this value only as a reference value because actual opening may differ from the current data in case of idle speed actuator breakdown. Now let's study the step motor type idle speed actuator. The step motor type idle speed actuator is installed on the throttle body and controls the engine speed by controlling the airflow bypassing air. The step motor has 6 terminals. Battery power is supplied to 2 terminals through the control relay. The others are connected to the ECM and 4 coils are controlled sequentially. The motor rotates by the on and off of the terminals in sequence. In reverse rotation, it is controlled in the reverse order. As for motor rotation, one rotation consists of 24 steps, and 5 rotations can be made because it has 120 steps. There are several ways of checking the step motor: checking the resistance, checking the waveform, checking the operation, and checking the current data. To measure the resistance, first of all, measure the resistance of the 4 coils after disconnecting the connector. Then we can check the internal coil condition of the step motor. To measure the waveform at the wirings to the ECM. In case of sudden acceleration or deceleration, the step motor waveform should display as shown on the screen. In the step motor waveform, voltage at the off state should display the curve like the screen. If not, there is trouble in any one of the 4 ECM control wires. If the waveform shows the 12 volts constantly, we may suspect the fault of wire or the ECM control. If 0 voltage is displayed all the time regardless of acceleration or deceleration, we may also suspect the step motor coil disconnection or any wire disconnection from the battery positive terminal to the step motor. In addition, voltage at on state should be close to 0 volt, as shown in the figure. If not, there should be trouble in the ECM and wiring from the step motor to the ECM earth. To check the step motor operation, Remove the step motor from the engine and disconnect the battery. Install and connect them after 15 seconds and turn the ignition key to the on position. Then check the step motor movement. If the step motor does not move smoothly, we may suspect the motor stuck, defective wiring, and defective ECM. Step values in the current data is the calculated figure by the ECM. Actual opening may differ from the current data if the step motor has a problem.
فراموش نکنید که توی کانال سابسکرایب کنید و کانال رو با دیگر دوستانتون به اشتراک بذارید. تا ویدیوی بعدی روزگار خوش.